Hello, everyone. Today is June 29th. This will be our last lecture. So everyone, I just want everyone to know, let me pull something open. So the extra credit is already done. It's due. Thank you for filling out the surveys. If you submitted the surveys, you got the full 2.5%. If the class participated, let me see, at a 78.13% participation rate. I can go ahead and show that to you. That way you can believe me. So we can see that the class did participate. Everyone should be seeing this screen at a 78.13% participation rate. So let me go to my email and see what that means. I think that means a 1% for everyone bonus. So even if you didn't fill it out, let's show the screen. So since we were at that percentage, let's see, at 70%, you get 1%. So it's this right here. So at 70% response rate, you get a 1%. So everyone does get a 1% bonus towards their final grade, regardless if they submitted the document or not. Another announcement that I have to make, the final exam is due today. I have to make this announcement, and let me see, because I think we have quite a few students that have to take the exam. I'm just checking right now to see how many actually have to take the exam, and I'm going to send out an email reminder. There is no more makeup. There won't be a makeup because I have to get the grades in, so let's see where we stand on that. So currently, right now, we have 17 responses. So, we have 15 students that still have to do the final exams. That's about half the class. So, my suggestion is to get the exam done today, as there will be no makeup time. And the interesting thing about this exam, it says the average time to take the exam should be about 46 minutes. So you have more than enough time to take the exam. I can just see what the average time is right now for students. Our average time for the 17 students who've taken the exam has been 1 hour and 23 minutes. So you're provided 3 hours, and if the average time is 1 hour and 23 minutes, you're given more than double the amount of time to take the exam. So our best bet is to look over the material before you take the exam, because it is on a time. It is timed. I just curious to see if anyone actually took the full 3 hours. The longest anyone has taken for the exam is 1 hour and 58 minutes so far. So, the shortest time was 38 minutes. So I have a range between 38 minutes and 1 hour and 58 minutes. So the exam is not designed to take the full 3 hours. I just give that amount of time in case you come into any technical difficulties or anything like that. So let's go ahead and go into the material. And what I might do is I'm working with a Macmillan rep today at noon to get the Organic Chemistry 2 website, hopefully online. But I'm working with them. I want to make sure all the materials are up there. I don't think I'll post the syllabus until Monday. I know that's July 4th, but that's probably when I'll have time to work on it. It's going to be the same point breakdown as what we had for Organic 1. It's just that the topics are we're just going to continue on. So Organic 2, we're going to start on chapter 12. So if you want to get a head start, what I'm going to try to do is hopefully I can get that loaded today. And then for those students who want to work on chapter 12 homework, I'm going to try to post that. And I'll try to get the PowerPoint notes for chapter 12 up too. So I think I'm sharing my screen now. So yeah. All right, let me plug in my And this won't take a whole lot of time because, you know, like I said, we're not going to have any homework on chapter 11. I can assign some homework if you want it, but it'll be worth 0 points. So, I mean, just let me know if you want me to assign some homework. We can make it worth 0 points. That way, you know, you can get a little bit of practice in if you want to, but, you know, that'll be up to you whether you want me to do that or not. So let's see. So it says right here, you know, propose an efficient synthesis for the following transformation. We have 1, 2, 3, 4, 5 carbons here. I think we have 7 here. We have to figure out a way to make this compound. So in this case, you know, we're trying to see how we synthesize that. I skipped the previous slide because what happens is you have the sodium amide, right? There's a hydrogen here. So this amide is going to take that hydrogen. It's going to make this carb anion. So we're going to form a carb anion. Well, what does that mean? We're going to have a negative charge here. Well, if we have a negative charge and then we have this ethyl iodide, well, you know, you can see that we're probably going to have an SN2 reaction, right? Substitution nucleophilic bimolecular. Now we're going to come here. It's concerted, so that means it all happens at once. And that's how we get this here, this chain right here through that SN2 reaction. It says dissolving the metal reduction converts alkynes to transalkenes. So to convert this from a triple bond, you know, I'll just call it 3 triple bond to a double bond. You know, we're going to use these reaction conditions, and that's what's going to happen. So it's a 2-step synthesis. It says it's extremely important to number each reaction in the multi-step synthesis. You know, first we started with taking off the hydrogen, then we did an SN2, and then we got rid of the double bond. We reduced it from a triple bond to a double bond. So really, this wasn't too bad right here. It says for retrosynthetic analysis, it just means that we're going to solve for the reaction sequence in reverse order. That's all it means. So we begin by solving for the last step in the synthesis first. And that's what we did. Here it says perform a retrosynthetic analysis for the following synthesis. We see you have an alcohol here. We have 1, 2, 3, 4 carbons. We have 1, 2, 3, 4 carbons. We don't change the number of carbons. We just change the functional group. So it says an alkyne can be installed on this carbon skeleton by elimination of the following 3 dibromides. They give you 3 different dibromides to be able to look at that. As we call that, so they're just given an arrow designation. So we have just solved for the last step in the synthesis by identifying a reactant we can use to produce the final product. It says use this excess sodium amide and water. So to make that dibromide, we need this alkene. Sometimes I like to go right to here. So I skipped a few slides, or a slide. But I think this is more important. So we have this triple bond. Let me see. So to get this from an alcohol to a double bond, we use these conditions. From a double bond, we add this bromine here, and then another bromine can come in and attack at either end. And then we use the sodium amide to get this down to a triple bond. And that's through elimination. You can see one hydrogen here, that base comes in, forms a double bond, that bromine leaves, now we have a double bond, and then we have a hydrogen here. So then you can think of that happening here. Here's your triple bond, this bromine takes off, now you have this. So overall, here's the multi-step sequence. So there's 5 different steps with this one. Yeah. Then the book goes into this, what it's called green chemistry. And basically this is how much waste are we producing on the product side? The less product waste, the better. So they call this either poor atom economy or good atom economy. So you want to prevent waste, use less hazardous substances, use safer solvents. The best one would be water if you can, and maximize atom economy. And what do we mean by maximize atom economy? If we have these reactants right here, we can see that on the product side, we don't see mercury, we don't see this one, we're not seeing sodium. So the atoms in red are waste material. And here, the only waste material we have is a proton. So that's better atom economy to generate the same product. So in doing so, if you're preserving, you are saving, financially, it's more feasible too. So green chemistry refers to reactions that are more environmentally friendly. They use catalysts rather than stoichiometric reagents. We have energy efficiency. Reactions performed at room temperature are more efficient than those requiring heat. And renewable feedstocks using sources such as grains or corn as a source of carbon as opposed to petroleum. But then, if you deplete the amount of food, you might run into other issues. So it may not be the best idea to deplete your grain or corn. Your grain, corn is grain. You also have wheat, buckwheat, and all that kind of stuff. And right now we're seeing food prices go skyrocketing along with petroleum prices. So, just you have to keep that in mind. It says to build a molecule, you must be able to choose the right tools for the job. It is helpful to organize the reactions as you learn them into two sets of reactions. So you're looking at, are we changing the number of carbons? And are we altering the functional groups? So you can design your own problems if you want to. I mean, you can swap with a classmate. You can see right here, if you gave them this, how would you make that? Then, you'd give them, they think, oh, we need this. And we're going to take off a hydrogen here. That's going to go create this carbanion and do an SN2 reaction to get this. So that's kind of the idea. Or if you're given this, how would you make this? Same thing. This is sodium amide. This is a good base. And SN2 reaction, you could see how that could be taken on. H2 and Lindlar's catalyst, this will reduce this down to a double bond. So if you gave them this, they kind of have to work backwards a few steps. Here's different ways to go from this double bond to this alcohol right here. And that's it. So does anyone have any questions for me? So I knew it'd be a shorter lecture today, but that's okay. It gives a time for those who need to get the final done. So for grades, I won't be able to calculate the grades until, well, tomorrow, because everyone's still taking, we have half the class still taking the final. So if you want to discuss your grade, please email me and then we can schedule an appointment. So I think that's going to be the best thing to do, is just email me so we can schedule an appointment, and then we can take it from there. So everyone have a great day, and I will probably see most of you next Tuesday in organic chemistry too. So have a great 4th of July weekend, and just enjoy yourself and stay safe.